Hi, this is Shilpa. In this video, I'll walk you through my optional assignment one. So this is a part one of the assignment. For this Python tutorial code walkthrough, I'll start with the first section, comments and printing. I'll run the cell. So this is the output. So what here I'm doing is here I use simple print statement like hello world. It's just a string. And then here I'm using the math of like 5 plus 4. So it's doing the sum equal to 9. But I can use a mathematical operator plus here even for concatenating a string. So for hello and word, so it gets concatenated and prints hello word. So in the next cell is variable and data types. I'll run this cell. So this is the output. So in the variable and data type section, I declare variables like name, age, height, and is student. I then call the type of on each one to show their data types. So we can see that like for the name it is string, for age it is int, for height float, and for each student it's true, that means it's boolean. So it basically prints the type of the variables that we have declared here. And next is mathematical operators. So in this math operators, I demonstrate here the basic operations like addition, subtraction, multiplication, division, float division, modulo, and exponentiation. This section shows the difference between a difference between regular division and float division. How we can use modulo for things like checking even or odd numbers. So we can see like for this modulus, it shows the remainder, and for this regular division, it shows the floating. But for this float division, it actually shows the absolute value. And next is string and slicing. In the strings and slicing section, I work with a string. For example, rand string equal to this is a string. I use method like strip to remove extra spaces and length to get the length, and also slicing. I also use it for slicing, and for this range here, the range here to show how we can access part of the string. So we can see the result of these respective print statements, and we can see how the string has here it is just printing the string, here it is giving me length of the string, and it's a different function, like I'm performing different functionalities on the string. Next is list. I create a list, for example, grocery list like juice, tomatoes, potatoes, and bananas, and then I would say print grocery list of 1. So I create a list, and also like I'm performing indexing here, slicing, appending, and then I'm removing. And I also demonstrate here like a nested list and how to loop them with nested for loop. Here it is. So we can see the output here. Next one is tuples. After list, I demonstrate tuples with something like pytuple, and we can see I have defined the tuple here. And for the new list, I say list of pi, and I show that tuples are similar to list but immutable, meaning we can't change their elements once they are created. This is helpful when we want fixed collections of data. So, and then after output, we can see the length of it, minimum of this tuple, and then maximum of this tuple. Next is dictionaries. Here I create a dictionary with the key value pairs, as we can see here, like a simple phone book or a student information. And here I am showing how to add update, delete entries, how to iterate over keys and values using dot items. This maps directly to the slide content that was given for the reference, and we can see the output here. It's We are saying here from the dictionary supervalence get the Captain Cole's value pair. So it is Leonard Snart, and also here we are printing the length of the dictionary, it is 3, and also we are printing only the keys of this dictionary, and also we are also printing just the values of the dictionary. Next is conditional statements. In conditional statements I use if, elif, and else. So it is just like that. If initially if you have defined age is 30, and what I'm trying to define here is if age is greater than 16, then I will be printing this, otherwise I would print this. In this case, if the age is greater than or equal to 21, I would print this. Otherwise, in the other case, if the age is greater than or equal to 16, then I would print this. So if all this doesn't, if all this condition is not met, then I would print you are too young. So since I have given age equal to 30, so where 30 is greater than 16, yes, so you're old enough to drive. And then it next comes here, age is greater than or equal to 21, yes, it meets this, and then so you can drink. Then next is loops. The loop section shows how to use for loops to iterate over list and range list here, yeah, and then range and string. I use example like for x in range of 0 to 10 to loop over a sequence of numbers. I also use nested loop for 2D structure like a list of list here, and which is useful when working with tables of values. And then we can see the output of this respectively. While loop and break or continue. Next is while loop with break and continue. I use a while loop. Here you can see I use a while loop that keeps running until a certain condition is met. For example, searching for a random number. I show break to stop the loop early and continue to skip to the next iteration, which I have not done here, but we can use that for in any cases required. So we can see how it works. So the number equal to 7, and till so it's 7 is less than or equal to 10, yes, it's met, and then further conditions keep repeating till when comes to a point where I is greater than 10. And then next is functions, yeah. I show how to pass parameters, how to return values, and how to give default parameters values. This part connects onto the slides that explain modular programming. So we can see the output is printed. And then for user input, I use the input function to read data from the user, and I'll just try to run it. Yeah. For string formatting, I use techniques like format. Format can be used and f strings here. For example, I may try something like print like my name is with curly braces too, and otherwise we can use formatting like this, like how I have used in this cell. So once I run this, you can see that like it has referred all these references. Next is file input output. I show how to open a file, write to it, and then read it back using a with open. and this automatically handles closing the file and is recommended way to file operations in Python. So when I run this is the output. For exceptions, I demonstrate try, except, and possible finally. I intentionally cause an error like dividing by 0. Mm, no, like like by dividing by 0 or converting invalid input, or give a file which does not exist. So when I run this, you can see the error here, like no such file or directory. So in that case, it catch it with an exception block, and then finally it prints this one, finished with error handling. This shows how we can print our program from crashing and instead handle errors gracefully. Next is objects and classes. Here I define a class with name, height, weight, and sound. I implement methods like you can see like toString and to return formatted description of the object. Then I create an instances of the classes here and print the details. This section connects to object-oriented programming concepts of the slides. Next is inheritance. I create a dog class here that inherits from animal and adds an owner attribute here. I override or extend methods as needed and then initiate a dog object such as spot, and then call spot to string. This shows how code reuse work in Python classes and how child class can build on parent classes. Next is modules and random numbers. I demonstrate how to import modules using import random, then I call the function like ran init 0, 100 to generate a random integers. This, and then if I run it, this is the output. This illustrates how we can use the Python standard library to add functionality without writing everything from scratch. Next is lambda and map. I'll run this. Yeah. I define a small anonymous function like double. We can see in this line, like lambda x into 2, and then I apply map to list, for example the list of map this line to square all the numbers in a single expression. This highlights functional style operations in Python and how we can write a concise data transformation. Finally, I have a small end message section that prints a confirmation like all direct Panas tutorial code executed successfully. So when I executed it, this is what is printed. So this lets me verify that the entire notebook ran without any errors. Thank you.